Let's talk about something we've all experienced, that sudden, annoying moment when the power cuts out and you're plunged into darkness. A circuit breaker just tripped. But, what if I told you that little click is actually the sound of your house saving itself? Yeah, we've all stood there in the dark and asked this exact question. You're just minding your own business, maybe you fire up the microwave, and poof, silence. Everything's dead. And it really feels like something broke, but I promise you it's actually a success story. Okay, so let's bust the biggest myth right off the bat. Most of us think, my breaker must be old, it's broken, it's faulty. But the reality? That breaker is your own personal bodyguard. It's not failing you, it's doing its job perfectly, protecting you from something much, much worse.
So what even is this thing? Well, just think of a circuit breaker as a little security guard for your home's electrical system. That's its only job, to watch the flow of electricity. And if that current gets too high for any reason, a little mechanism inside heats up, bends, and click, it shuts everything down. It's simple, but it's absolutely brilliant.
So what would make that current become unsafe? Well, let's get into reason number one, which is by far the most common culprit. A good old-fashioned circuit overload. An overload is pretty much exactly what it sounds like. See, every circuit in your house is like a road, and it's only designed to handle a certain amount of traffic. When you plug in and turn on too many things at once, say your hairdryer, the space heater, and the TV on the same circuit, you're basically asking those wires to carry way more electricity than they were built for.
And that's when a chain reaction starts. You add more devices, the electrical demand goes up, and the wires inside your walls start to get hot, like dangerously hot. But just before that heat has a chance to cause real damage or even start a fire, the breaker senses it and click, it kills the power. It's literally a fire prevention system hiding in your wall.
Now, let's move on to the second reason, which is a lot more sudden and, frankly, a lot more serious. We're talking about a short circuit. So what's happening here? Well, normally, electricity has to flow all the way through your appliance to do work. But in a short circuit, something's gone wrong. Maybe a cord is frayed or there's faulty wiring, and the hot wire actually touches the neutral wire directly. This creates a shortcut, an electrical superhighway, and the current just floods through it like a tidal wave. We're not talking about a slow buildup of heat here. A short circuit creates a massive, uncontrolled, and instantaneous surge of electricity. It's way, way more than the circuit can handle. So the breaker's response has to be just as fast. It trips in a tiny fraction of a second to prevent a truly catastrophic failure.
Here's probably the easiest way to tell them apart. An overload is a slow burn problem. It's a traffic jam caused by too many cars on the road. But a short circuit? That's an instant crisis. That's not a traffic jam. That's a bridge collapsing and causing a 10-car pileup. One is about capacity, the other is about a critical, sudden failure.
And that brings us to our third reason, which is a really sneaky one. It's a hidden danger called a ground fault. Okay, so imagine your electrical circuit is like a sealed garden hose. A ground fault is like a pinhole leak in that hose. The electricity is actually escaping its proper path, the wires, and it's trying to find the fastest way to the ground. And the scary part is, sometimes, the fastest path to the ground is right through a person. This is exactly why you see those special outlets in your kitchen and bathroom, the ones with the little test and reset buttons. Those are GFCIs, or ground fault circuit interrupters. Their entire job is to detect even the tiniest leak of current, way smaller than what would trip a normal breaker, and shut the power down instantly. It's a device designed specifically to save you from electric shock. All right, so your breaker tripped. You get the likely causes now, but what should you actually do in that moment? Well, here is a really simple and safe test you can do yourself. So let's walk through this. First thing, go to the room where the power is out and unplug everything from the outlets on that circuit. Step 2. Go to your breaker panel. You have to flip the switch firmly all the way to off first and then back to on. Now this next part is really important. If it stays on, great. You probably just had a simple overload. You can start plugging things back in one at a time. But, and listen closely, if that breaker trips again instantly the second you turn it on, stop. Don't touch it again. That's a huge red flag for a short circuit or another serious issue, and that's your cue to call an electrician. And really, that's the main thing to take away from all this. The next time you hear that click and the lights go out, try to take a breath. Instead of getting frustrated, just remember that a small, simple device did its job exactly right to keep you and your home safe. It's not a problem, it's a solution.
So I'll just leave you with this final thought. A breaker that trips once in a while is a healthy breaker.
The truly dangerous circuit breaker isn't the one that trips too often. It's the one that never, ever trips at all. Thanks for tuning in.